This talk reveals the discovery of tiny chips of nanothermite in the World Trade Center dust from 9/11. Thermite is an incendiary compound invented in 1893 and is made by mixing powders of iron oxide and aluminum. Once ignited, the aluminum grabs the oxygen from the iron oxide. This reaction releases clouds of aluminum oxide and generates very high temperatures in the elemental iron. This high-temperature iron easily melts steel. Tiny spheres of iron were also discovered in the World Trade Center dust and are evidence that a thermite reaction took place on 9/11. Nanothermite, a highly engineered, energetic nanocomposite, was conceived around 1990 and by 2000 had been weaponized and was manufactured in large quantities in top-secret military laboratories. This nano form of thermite does not just burn extremely hot, it is explosive. In this video, Dr. Stephen Jones announces the publication of the recent paper, Active Thermitic Material Discovered in Dust from the 9/11 World Trade Center Catastrophe, published April 2009. The implications of this new peer-reviewed paper are profound. Stephen also updates us on various facets of the quest to repudiate the official conspiracy theory about 9/11 and describes current efforts to create a legitimate investigation with real subpoena power.
Stephen Earl Jones earned his bachelor's degree from Brigham Young University in 1973, graduating magna cum laude. He received his doctorate in physics from Vanderbilt University in 1978. His PhD research was conducted at the Stanford University Linear Accelerator Center and his postdoctoral research at Cornell University. He taught physics at BYU for over 20 years. In addition, from 1979 till 1985, he was a senior engineering specialist at the Idaho National Laboratory in Arco, Idaho. And from 1982 until 1991, he was principal investigator for experimental cold fusion for the U.S. Department of Energy Division of Advanced Research projects. From 1991 until 1993, Professor Jones researched fusion in condensed matter physics and deuterium for the U.S. Department of Energy and the Electric Power Research Institute. And since mid-2005, he has applied his scientific expertise to research on the destruction of the World Trade Center skyscrapers. He was a founding member of Scholars for 9/11 Truth, and in late 2006, he was instrumental in the establishment of Scholars for 9/11 Truth and Justice, dedicated to 9/11 research utilizing a scientific method. He is co-editor of the peer-reviewed Journal of 9/11 Studies. So I'm very honored and proud to present to you Dr. Stephen Jones.
Well, thank you all. It's a pleasure to be with you here in Sacramento. And as David mentioned, our paper on active thermitic material discovered in the World Trade Center dust has just been published earlier this month, and Jeanette McKinley explained how that dust was acquired, at least one of the samples. We report in this paper on 4 separate samples. As I provide a little introduction to this research that we've done on the World Trade Center dust, we all saw these voluminous clouds of dust that were produced as the buildings were destroyed. So we've looked at and probed very carefully, this team of scientists, 9 of us, looking at the dust to determine what information, and there's a great deal of information actually in the dust that tells us what happened that day. Information about the presence of an explosive or pyrotechnic material that has been ignored in the official reports. In fact, to my dismay, NIST, the National Institute of Standards and Technology, has in fact refused to look for explosive residues in the World Trade Center dust. But we have not. We have proceeded, and I like this quote from Mahatma Gandhi. He said, "When I despair," which I want us to avoid, so I bring this to your attention, "I remember that all through history, the way of truth and love has always won." That's a remarkable fact. "There have been tyrants and murderers, and for a time they seem invincible, but in the end they always fall. Think of it, always." I'm convinced that he's right about that, and that provides a great deal of hope. I would like to talk a little bit about the collapse of World Trade Center 7 and the destruction of the towers before getting into our detailed analysis of the material found in the World Trade Center dust. So here we have on the right, lower right, a photograph of the World Trade Center 7 building. It's obscured by dust. We're looking across the World Trade Center 7 plaza. It's interesting. This is in the afternoon, and if you look to just to the right of center, that tall building is World Trade Center 7. And it collapsed about 7 hours after the collapse of the towers. You do not see there a raging inferno of fire because fires were rather limited from what could be seen external to the building, certainly. And they were random. And yet the building did collapse straight down, pretty much onto its footprint at about 5:20 p.m. in the afternoon on 9/11. Now, the World Trade Center 7, here's a more distinct photograph now on the right, had 24 steel beam core columns and 57 perimeter columns. It was solidly built, as you might imagine. And here we will get to see the collapse of World Trade Center 7 on the left, and the collapse of a building, I believe that one is in Oslo, Norway, a known controlled demolition on the right with explosives. Okay, you can see how similar these appear from the videos that we have of the collapse of World Trade Center 7. Notice that it proceeds basically straight down, and we'll talk about the free fall during a period of time for World Trade Center 7 in a minute. It's noteworthy that the 9/11 Commission in their report failed to even mention the collapse of World Trade Center 7. Hence, we see already the need for a new investigation, a thorough investigation that will not ignore the collapse of Building 7. I support Jeanette McKinley and in her support for the New York City CAN referendum, and I've already contributed to that, and I hope that you will do that as well as we seek this new investigation. That's one avenue for an investigation with subpoena power, which is very important in this quest for a fair and open investigation. I'm also encouraged by President Obama as he says there will be more transparency. Let's hope that that is the case as we investigate again the events of 9/11. Now, NIST last August came out with a preliminary report, finally, after considerable delay, on the collapse of World Trade Center 7. And they said, quote, "Failure of a floor beam and fire is a rare event, and indeed there have been many building fires that have not resulted in even local failures of the floor system." They also admitted that there had never been a complete collapse due to fire, which is true. So here's what they stated as their challenge. The challenge was to determine if a fire-induced floor system failure could occur in WTC 7 under an ordinary building contents fire. Now, you see, they're explaining that they're looking for a fire-induced explanation for collapse of the building. Which already seems to have the blinders on. We keep hoping and encouraging them to look for residues of explosives. So how did they proceed? Well, first of all, they did not test any of the steel in World Trade Center 7 to look for the effects that they could learn from actual hard physical evidence on the steel. Instead, they proceeded with computer modeling with parameters. These are adjustable inputs into the computer model. So basically, it's a black box. And one of the parameters or assumptions that they plugged in to their computer model was this. The steel was assumed in the FDS model to be thermally thin. Thus, no thermal conductivity was used. Now, let me try to explain what they're talking about here. Let me go to this. No thermal conductivity was used. I happen to have with me here a I brought along a rusty nail. It's kind of funny, I suppose, but there's reasons we'll get to later. If I started to heat this with a flame, it would slowly, the heat would slowly conduct across the metal, even though iron and steel are not very superconductors, they're very good conductors, but they do conduct heat. It's certainly not zero. And I would feel that heat after a short time. Maybe you've done that with a pin or a needle. As I've worked on slivers, I've had to heat up a needle with flame, and that heat transfers along the needle, stainless steel, for example, to my fingers quite quickly in just a few seconds. Well, what they did is they turned off the thermal conductivity. Now, nature won't let you do this, even if you are a national federal laboratory, under, incidentally, the Department of Commerce, I should point out. Okay. Now, secondly, another parameter that is an observation in their model, even after turning off the heat transport and burning office materials near this critical column, column 79, they said in their report, it appeared likely the critical damage state, in other words, the failure of this column, occurred between 3.5 and 4 hours. Now, burning office materials, we're talking about chairs, papers, carpet, desks. Some of you have made a fire, a bonfire. Does it last 3.5 to 4 hours with immense heat? No, actually, from our experience. And NIST, interestingly, had previously published data on heat release during the burning of office materials. This is in one of their earlier reports, and you can see from the plot, there's two. The red is the FDS model. The black is experimental data. They don't line up exactly, but the point is that by 2,000 seconds, the fire is way down compared to what you had at about 600 seconds. 600 seconds is 1/6. It's about 10 minutes into the fire. So you see that by the time you get to 40 minutes, towards the end of the plot, then the heat is diminishing, just as you would expect if you built a campfire or even a bonfire. The fuel burns up rather rapidly, and you don't have anyone in the building continuing to push office materials towards this critical column to keep this fire going for 3.5 to 4 hours. Nevertheless, that is what they somehow assumed, that there would be this intense heat for that period of time. Again, the critical damage state occurred between 3.5 to 4 hours. Now, you can't just let the office material fires continue to burn when the experimental data shows that the heat diminishes rapidly after about 15 to 30 minutes. And secondly, you can't turn off the heat transport. In other words, the heat being conducted away from the critical column because there are connecting members connecting to these columns so that the heat is transported away. The conductivity is not zero. Now, in a computer model, you can do any crazy thing you want, but nature won't let you do this. And some of us feel very strongly that NIST should allow us to actually have their model so that we can test it and put in realistic parameters, predicting, of course, that if we do that, the building will not fail. Clearly, if it requires 3.5 hours of heating with no thermal conductivity, then when you put in some conductivity and reasonable values for the length of time for fires, then you'll get much different results. Now, in August, again, August 26th of 2008, physicist David Chandler and I both challenged NIST on their preliminary report, World Trade Center 7. For example, in the report, they said that they used a constant speed estimate in estimating the time for the fall of the World Trade Center 7. I pointed out this is not good physics. They also ignored an observed period of free fall, as David Chandler pointed out. So here's what David Chandler noticed. Now these are the dots are data points actually taken from videos of the fall of World Trade Center 7. And fitting a straight line over this portion, as you can see, fits the data points very well for a period of about 2.25 seconds. The acceleration works out to about 9.885 meters per second squared. The acceleration due to gravity is 9.81 meters per second squared. This is almost precisely the acceleration due to gravity. And we both, David and I, challenged NIST. This is a public meeting that is over the internet. It's kind of interesting. We sent in questions to NIST saying, look, your report, your preliminary report, has some big flaws and oversights and apparent errors. Can you look into this? And they did look into it, and here's what NIST came up with. Now, if you can remember that a little bit, that fit to the data. NIST, red data points, red circled data points. And again, looking at the actual videos of the collapse of World Trade Center 7, they did a fit, which is the red line, and indeed for a period of 2.25 seconds, just as observed by physicist David Chandler, NIST checked, and sure enough, there is free fall. Nothing in the way for over 2 seconds in the fall of World Trade Center 7. Now let's read what NIST says about this. This is their final report now, not in the preliminary report, but in their final report. I believe it was November of 2008, last year. And here's what they say. Quote, the slope of the velocity curve is approximately constant between 1.75 and 4.0 seconds. That's a time period of 2.25 seconds. A good straight line fit to the points in this range allowed open circles in the figure we just saw, allowed estimation of a constant downward acceleration during this time interval. Quoting NIST, this acceleration was 32.2 feet per second squared, 9.81 meters per second squared, equivalent to the acceleration of gravity g. Exactly, within experimental errors, the acceleration of gravity g. And then they go on. This free fall drop continued for approximately 8 stories, or 32 meters, 105 feet. So for over 100 feet, the building, as you look at the roof in both cases, is freely falling, nothing in the way. Now in the question and answer period, when David Chandler and I challenged NIST, are there errors looking at the drop of the building? Shyam Sundar said, well, free fall would mean that there's nothing in the way, and that can't happen because as the building collapses, there's a lot of material in the way. I'm paraphrasing. That's basically what he said, and we agreed with that. But now, from the data, NIST is constrained to admit that there was free fall drop for a time period of 2.25 seconds, which doesn't sound like much, but when things are dropping over 100 feet at free fall, that is significant. So this demonstrates, this free fall drop, that there was nothing in the way. No beams, no structure, no concrete floors, no significant mass. Now, how do you get mass out of the way? Explosives. Is there any other way? They didn't answer. In a model in which you have the floors still there because you didn't use explosives, so the floors are intact, as the upper structure hits the floors below, the stationary floors, it slows down the structure. It's just like when you hit, this does happen to us occasionally, you hit something in the way of your car, perhaps a smaller car. It doesn't matter how small it is, it slows you down some. That's conservation of momentum. In order for there to be free fall, which means nothing slowing you down, it means there's nothing significant in the way. And they did not explain, they don't answer how this could happen, unfortunately. Now, I thought they would, after we caught them on their error, they admitted, they checked the data. Yes, there is free fall. It's amazing. You'd think they would change their conclusions. Instead, they simply assert without proof that this period of free fall for over 100 feet, followed by about 1.5 seconds of impeded fall, is consistent, that's their word, consistent with their results of global collapse, as they discuss in chapter 12 of their report. But in other words, they didn't change anything in chapter 12 of their report. They just said, oh, yeah, free fall, yeah, sure, that's consistent. Now, a black box computer model, which no outsiders are allowed to test so far, hoping to get around that with, for instance, NYC-CAN, that commission should be able, hopefully, to get a release of this model. Do you think we're satisfied just to sit back and say, oh, well, sure, it's consistent, whatever you say, NIST. After all, you're a federally funded laboratory. We will believe whatever you tell us. We're not satisfied as scientists. I'm embarrassed, frankly, that NIST makes this assertion without proof. It is good that they at least admitted that there was free fall. These are some views of the World Trade Center dust. We see these remarkable red-gray chips, upper right. We'll talk about those some more. And remarkable spheres in abundance in the dust. Many of these are rich in iron and aluminum and silicon together. A very unusual combination, which is not from melting of steel in the towers because of the aluminum and silicon present in significant amounts in many of these droplets. Previously molten nature of these droplets is shown by the fact that they have formed into spheres. When you blast water in the air, it forms into spheres by surface tension. Liquid metals will do that as well. They form into spheres and then cool, and you find all these spheres just in very large quantities then in the World Trade Center dust. Now, here are some close-up photos of the red-gray chips. Can you see in the right-hand photo, you see the red side, and then the insert shows one of these red-gray chips turned on its side, so you can see red on one side and this shiny black-gray surface on the other. Very characteristic, very interesting. We find it in all the samples that we have examined so far, the World Trade Center dust, which is 6 samples by Dr. Ferrer and myself. 4 of these are reported on in this article. We keep looking at more samples. Others have observed these red-gray chips as well. This photo was taken by Mark Basil, a scientist in New Hampshire area, and he had a sample sent directly to him, I know, of the World Trade Center dust. Also observed in France by Dr. Frédéric-Henri Coignier. And you can see very clearly in this photomicrograph by Mark Basil, the red and the gray layers. Very distinctive, very unusual and striking. Now, this is the electron microscope and XEDS system used at Brigham Young University. Dr. Ferrer is the lab director. He does excellent science and checked and rechecked the data that went into this paper. Most of the photomicrographs and XEDS, well, certainly I took a lot of the photomicrographs through the optical microscope. He did most of the electron microscope, the SEM and BSE images that you'll find in the with this machine, that you'll find in this published paper. Okay, here's the paper as it appears now online. It is an open journal. We selected a journal that would allow us to publish a lot of data. There are something like 33 figures, I can't remember exactly, 33 figures, color, 25 pages. That's a long paper. And this journal was willing to work with us. It took a long time, a very tedious peer review process, many pages of peer review on the initial submission, followed by this paper. This is a photo of Niels Harrit, who became the first author, long story there, and great fellow, associate professor at the University of Copenhagen in Denmark. He's been speaking out in Europe, for instance, Denmark and Paris. I know he's spoken out on these results and on 9/11 in general. Of course, he's very skeptical of the official story of 9/11 and agrees with the conclusions of this paper, which are the red material in these chips is explosive or pyrotechnic material and should not have been in the buildings. That's his statement is this material should not be in a commercial office building, certainly not in these quantities, as we'll see, some 9 plus tons of this red material in the World Trade Center dust, extrapolating and estimating, but that's a lot of material from what we've observed. I'll go through those numbers in a minute. We see these chips, the same characteristics as we'll see in all 4 samples. So we do a consistency check between the various collectors, and we see the same signature in all 4 samples. This is now proceeding to a higher magnification. This previous was an optical microscope. Proceeding to higher magnification in an electron microscope. We see the red layer here on top and the gray layer below. At this magnification, we can already look at and sample the red and gray layers to get an overview of the chemicals present. We use X-ray energy dispersive spectroscopy. That will be on the quiz. Please make note of it. And at first we look here at the gray layers, which show oxygen and iron very clearly, a small carbon peak. And the question arose, I had this question early on compared to now. Perhaps what we're seeing is rust in the gray side, and the red is just paint, so we're going to check that hypothesis. We check very clearly. Looking at the red layers, however, there is no zinc, no manganese seen either. The composition, the nominal composition of A36 steel, as used in the World Trade Center towers, has about, 0.8 to 1.2% manganese. So where's the manganese? You look at that bottom plot, for example. These are the 4 samples showing essentially the same chemical signature. The principal elements are the same. Anyway, no manganese and no zinc. It's starting to not look like steel from the buildings because of the lack of manganese, and not like paint either, not like primer paint, as we'll see, because of the lack of zinc. Notice the elements that are there. Carbon, significant peak. Oxygen, aluminum, silicon, and iron. Okay. The one peak, number 3, has a small amount of calcium, potassium, and sulfur, but that could be some contamination. Dr. Fair was very careful to break these, if you can imagine these small chips, that he broke a piece and then looked at that fresh surface. There's so much calcium sulfate in the dust that you can still quite often see calcium and sulfur showing up just for that reason, because of the wallboard. Okay, now here's a paint, the primer paint used by Tenamec, supplied by Tenamec for the World Trade Center. We see that in the pigment, this is from Appendix D of the NIST report. We get facts from NIST, and they simply report the pigment and the components in the primer paint, which is high in zinc, magnesium, aluminates, calcium, and so on. But the absence of zinc, again, shows that this is not the primer paint. Even Frank Greening admitted that, if you know Frank. Thank you, Frank. The zinc is not there. Let's go back. Zinc is not there. And others have said, well, maybe this is somehow, as the buildings fall, you just get a mix of, aluminum and zinc. Mixes up, and you get this wonderful red stuff. Sorry, where's the manganese, first of all? And where's the other junk that we find in the dust, which is zinc and chromium and calcium and so on in abundance. But you see, those are not seen in abundance. There's a little apparent contamination in 3, but the characteristic signature does not show any zinc or manganese. Now, as you'll read in our paper, which I hope you will read, let me ask for applause. How many have actually read at least part of this paper? Okay, that's good, but it's obviously not all. So I'd encourage you to read it. It's not hard to find. If you Google, for instance, Harrit, Open Chemical Physics Journal, it should pull it right up for you. Red gray chips is a good way to Google for this too. So I soaked some chips in paint solvent working with Dr. Fair. We found, this is one of the early tests we did, the chip does not dissolve. Now, paint, which we also soaked in, I bought the solvent, it's methyl ethyl ketone, purchased it at a hardware store, it's a paint solvent. So I put chips of paint in there and they dissolved. Certainly the paint got flimsy, and then you see dissolution. But these chips did not dissolve at all. And there's no zinc, and now this, it's just not paint. Instead, what you see in these photographs is that the red portion swelled. The gray-black portion did not seem to be affected by the solvent at all. The red portion swelled, and can you see in the right photo the porosity that's now evident in the chip, the red material? And perhaps you can notice that there's some red material, and then with pores, this is primarily silicon dioxide, silica, with some iron oxide mixed in. And then in the left-hand side of this photo, the right photo, you see a silvery region. We found that the aluminum, elemental aluminum, separated out under the action of this paint solvent. Very interesting. Remember, there's a lot of carbon in here. The carbon does seem to break down. Okay, let's look at the data. Getting ahead of myself. This is in the paper. After the MEK soak, we now see regions where we see aluminum separated from silicon and oxygen. So if you look at the leftmost plot, you see a region, you see the silicon and oxygen, a little bit of iron, essentially no aluminum. This is not aluminum silicate. It's not kaolinite, as some debunkers said. Oh, it's kaolinite, that's all it is. No, you can't use a paint solvent and separate the aluminum from the silicon oxide in an aluminosilicate. It's just a solvent. It's not a reducing agent, okay? So, and now if you look at the middle plot, you see a large peak of aluminum, very little silicon. Again, this is not an aluminosilicate because the aluminum has now increased dramatically, just has been pulled out of this matrix of stuff in the red material. The oxygen is much less than the aluminum, and we deduced, Dr. Fair is an expert in this machine, that the aluminum content exceeds the oxygen content significantly, and so there must be at least some elemental aluminum, which is one of the prime ingredients of thermite. There is also iron oxide, as shown in the rightmost plot, oxygen and iron. Here, the oxygen in each case was sufficient to completely oxidize the iron, unlike the aluminum, where the oxygen was insufficient to oxidize all of the aluminum. See the difference? So elemental aluminum had to be present. Some of it, at least, was element. You have little bits of aluminum, little particles of aluminum. You get an oxide layer that forms very rapidly. It's called passivation, and that occurs on the surface and actually protects the interior aluminum from being further oxidized. Sorry, science. To me, this is exciting. You look at that and you say, whoa, there's aluminum in there, elemental aluminum. It's not aluminosilicate because the silicon's separate, and there's iron oxide. This is not just elemental iron. We didn't find any evidence of that in the red material. So now we go on. to higher magnification, 50,000 power. It's Dr. Fair pushed it up, and this, he was the first to see this. I'm just getting goosebumps here again. I mean, I just, you see these grains. Can you see the extreme right there, the bright spots? And you see them more in the, like the center of the SEM image as well. These are grains, and they happen to be rich in iron and oxygen. And the aluminum is found in these plates. Can you see right near the center below that set of grains, there's aluminum. And then around this, there's this kind of a wavy material. This is an organic matrix rich in carbon. Now, this red material is most interesting to us because it has aluminum inside these plate-like structures. The plate-like structures are quite uniform in thickness from what we can observe with the scanning electron microscope, 50 nanometers wide. Plus, the iron oxide appears in these ultrafine faceted grains, approximately 100 nanometers across, and again, very uniform. Again, let me emphasize, this is not from the building collapsing with, sure, there's aluminum and iron and titanium and calcium and sulfur and zinc and copper in the building. But that's not what you see here. Here you see uniform, right? Grains. This is engineered material. I just, if you're a scientist, you just can't say, well, randomly, the building falls down and we're going to get a few of these things. No. And we get 9 tons of this stuff, so we extrapolate. So there's not building stuff randomly mixed together. But what can it be? Okay, now we'll discuss the thermitic reaction, which involves aluminum, elemental aluminum, and iron oxide, which are present in the red material. When these are ignited, as I show in this little demonstration experiment that I did, aluminum powder and iron oxide powder, you get aluminum oxide. Can you see the white plume wisping away above the molten iron? The molten iron is a yellow-white hot coming out of this reaction. It's extremely hot, and you get molten iron. You notice you start out with iron oxide, but you end up with iron. What happened? And you start out with aluminum and end up with aluminum oxide. Can you see what's happening? The aluminum grabs the oxygen from the iron oxide, and you get the end products, aluminum oxide, much of which comes off in this plume. It looks like smoke, except it's white. It's quite bright, and it floats away, fine white plume. And the molten iron then form, reduced iron. We'll see. But I want to just say now, while we're thinking about it, that this red material, when we ignite it, we get iron spheres. Many of these spheres are nearly pure iron. Not enough oxygen in them to be iron oxide, you see. Less than 1-to-1 even. So we get molten, because it was spheres now, iron that are formed from the red chips when we just heat them up to about 430 centigrade, as we'll see. They react and release a lot of energy, and then we get molten iron. Folks, this is the signature for a thermitic reaction. And we nailed it. It took a long time to nail it, but we did. We nailed it. One thing I'd like to get perfectly clear, if I can possibly, and I wish there's someone here from NIST who would listen to this. Thermite, I agree, is an incendiary, ordinary thermite, which means powders of aluminum and iron mixed together. And they burn as incendiary. So you see this molten material. This is ordinary thermite here in the photo. And you see the molten iron coming out of that. It's an incendiary. It melts things. But the ultrafine grain form is an explosive. It reacts very fast. The smaller the grains, the faster the reaction. That's been demonstrated in published papers. And we see, for example, this is from a Lawrence Livermore National Lab. Anybody here from Livermore? I welcome you. I'd like to discuss this with you. In fact, we have been in contact with Dr. Tillotson. Dr. Fair has been in contact with him. Haven't learned too much yet, but they've published papers, as we will see. To me, this is quite exciting. In the lower right, you see the explosion of this. It's called nanothermite or superthermite. This is the ultrafine grain. Okay, now a quick quiz. Superthermite is A, incendiary, or B, explosive? B. Okay, very good. Now, actually, you can tailor nanothermite, which is interesting, so that you can make it react faster, slower, louder. It just has all these variations. You can tailor it. But it can be explosive, is what I'm trying to say here, as you see from the photo from Lawrence Livermore National Lab. I had a BBC crew came through the lab, took photos, videos, of me and I think others in the lab as we worked on these red-gray chips. And interestingly, they asked Livermore if they could show this a photo from a published paper, and Livermore declined, would not allow them to show nanothermite exploding, but it does, you see. It's very important. Here's what I was looking for, this wonderful map. This is in the paper, so you can study it. A little bit of homework on your free time. It's just, again, just so exciting. Dr. Fair took these maps. Isn't that, whoa, look at that, So what are we looking at here? Upper left is an image through the electron microscope. You see the bright grains. How do you know they're iron and oxygen? Well, you look at the blue picture. That's for Fe. In other words, we're scanning over, looking for iron, looking for blue. The purple is aluminum. The green is oxygen. The light blue in the lower left corner is silicon, and the red is carbon. So you see where these things lie. And what we see is that we have iron oxide and aluminum, although here you can't tell real clearly whether it's aluminum oxide or not because there's so much silicon associated with the aluminum as this stuff is constructed and engineered. It wasn't until we did the MEK separation that we found the aluminum pulled apart from the silicon oxide and that we're able to nail the presence of metallic aluminum. Again, you can look in the paper. There's another SEM map there. But again, we have this intimate mixing of iron oxide and aluminum and this very tiny grains of this oxidizer. It goes back about 10 years before 9/11/2001. Certainly long after the buildings were constructed. I get that question. No, it could not have been put into the buildings when they're constructed because it had not been developed at that time. It's a new high-tech technology. And here's some of the uses. Livermore report in 2004, they go on. By introducing a fuel metal such as aluminum into the metal oxide silicon oxide matrix, energetic materials based on thermite reactions can be fabricated. I'm not making this up. This is, these national labs explaining this wonderful explosive material. Organic additives, hence the carbon observed, can cause the generation of gas upon ignition of the materials, therefore resulting in a composite material that can perform pressure volume work. Boom, right? Explosive work. Method, and they describe a method of making nanostructured, energetic materials, specifically explosives, propellants, and pyrotechnics, nanothermite. I'll let you read some more in the paper. Read the last paragraph. We have prepared fine powders, pressed pellets, cast monoliths, and thin films of the hybrid inorganic/organic energetic nanocomposite. Hence, we expect to see carbon, that's the organic portion, along with iron oxide and aluminum, just as we observe in this exotic, highly engineered red material. So, it has the proper ingredients for nanothermite, has organic and inorganic How does it compare with known nanothermite when ignited? Let's heat it up like they do at the national laboratories and find out. So here's what we did. It's done by Dr. Fair. The blue curve, the red done by Tillotson et al. At Lawrence Livermore National Lab. The red curve then is known nanothermite, and we see a temperature. So in this differential scanning calorimeter, it's on the quiz, okay, DSC. Okay, so you heat this material, any test material, slowly. In this case, we use their conditions, 10 degrees centigrade per minute in air, and you heat it up, and in their case, the nanothermite, they made it, they know what it is, that's the red curve, goes off at just about 500 centigrade. In the case of this, and the peak there is actually quite narrow compared to regular thermite. It's also at a lower temperature. I'll show you that in a minute. You know, this is the way we can distinguish nanothermite another way from regular thermite. The red chip, from the red material from the World Trade Center dust, I can't remember. Yes, it says McKinley. This is a McKinley sample, Jeanette. And look at that, very narrow, and goes off at about 430 centigrade. A little lower in temperature. The finer the material in general, the lower the temperature at which it ignites. The narrower the peak, the more explosive, you see, the faster the energy release. The World Trade Center red-gray chip ignites at a lower temperature than ordinary thermite, and it's narrower, this is called an exotherm, than even known nanothermite from just down the road here, Lawrence Livermore. At the Energetic Materials Center, Lawrence Livermore National Laboratory, published in this proceedings. On the left, you have ordinary thermite. On the right, you have nanothermite. If I can help you read the scale, the ordinary thermite goes off at about 900 centigrade, and their nanothermite goes off at just below 600. It's like about 550 in this case, centigrade. Again, the finer the material, the lower the temperature. So that distinguishes, again, nanothermite from ordinary. Notice how much broader the ordinary thermite peak is compared with nanothermite. This is like no paint you've ever seen before. Let's review quickly. The red material will not dissolve in MEK. This is after 55 hours. There's this hard chunk left. I've got a photo of it down at the bottom. It's highly porous, high in silicon. This skeletal silicon oxide matrix remains after long soaking, whereas ordinary paint dissolves. Resistivity differs. It's attracted by a magnet, the red material. It has carbon, silicon, oxygen, iron, and elemental aluminum, but no zinc on a clean surface, no magnesium, no manganese to speak of, no titanium, no chromium. So I'd like to see a paint that has that. Of course, it might be a fairly explosive paint, you see, as we're finding out. The iron oxide is in quite uniform grains that are approximately 100 nanometers across and faceted. The aluminum is found in plate-like structures. Again, I'd like to see a paint like that, but don't bring it too close to me when it's dry, please. Further tests that characterize these red-gray chips and therefore characterize the World Trade Center dust. You see, now we can tell when we've got World Trade Center dust because it has these striking, unusual red-gray chips in it. The red layer ignites at about 430 centigrade. The DSC trace is narrow, and it produces iron oxide spheres. Again, I want to point out, as we observe, that these are uniform grains, intimately mixed, nanoscale, narrow exotherm. This is an engineered material. This does not happen just from a building collapsing. I should add, we actually looked at dust from ordinary controlled demolition, so you have then this collapse of buildings caused by explosives, but ordinary explosives like C4. We looked at the dust in some detail, Daniel Farnsworth and I. for red-gray chips. This was the demolition then of the Stardust Resort in Las Vegas. No red-gray chips at all, and we plowed through a lot of material. Same way with the Key Bank in Salt Lake City. These are discussed in the paper. These are controls, and no red-gray chips in the controls, okay? Just in the World Trade Center dust that we've seen. Okay, oh boy. You can read some of this in the paper. I'll let you do that. But this is from an April 2001 conference in San Diego. And they say in the middle here, the breadth of the work ongoing in this field of nanothermite and other related nanoenergetics is roughly 10 years old. So it goes back to about 1991. It was available by 2001, when this conference was held in April. At this point in time, all of the military services and some DOE and academic laboratories, and certainly overseas laboratories as well, have active R&D programs at exploiting the unique properties of nanomaterials that have potential to be used in energetic formulations for advanced explosives. These results were published in MTEC Quarterly, Department of Defense publication, I understand. And as we look at this, that's what I was just quoting from, this meeting held in April 2001. Now look, this is from the article talking about the uses of this advanced energetic material, this nanothermite, for example. At the top, you see kinetic energy munitions. In the middle, you see thermobaric applications for nanothermite. And at the bottom, you see a very interesting application, a shaped charge. This explosive material can be formed into a shaped charge, just like C4, and can cut through steel, not melt through, right? You see the difference, right? Ordinary thermite is incendiary. Nanothermite can be formed into an explosive shaped charge. Now, it's not easy to make this stuff. This is again from the report making the nanoscale aluminum for these high-tech explosives. This was done at a naval facility. Incidentally, again, this material could well have been outsourced. I'm not saying it was necessarily done even in this country. That's a very interesting question, where this stuff was made and who made it and who ordered it made and who put it into the building. Those are the crucial issues. This shows what is required to put these materials together. Very high-tech process to intimately mixed ultrafine aluminum with ultrafine iron, again, out of this MTAC report. How much material was in the dust? I want to go through this argument quickly. We report in the paper, the first paragraph is a quote from the paper, 15 small chips having a mass of 1.74 milligrams, extracted from 1.6 sample of dust from which readily identifiable glass and concrete fragments had been removed by hand. The fraction then of red-gray chips was approximately 0.1% by weight in the separated dust. The unseparated dust is about 3 times that. A rough estimate of the amount of dust from the WTC destruction is estimated. I refer to work by Gregory Urich, 90,000 tons. He sent me an email actually about that. That brings us to about 27 tons of the red-gray chips in the dust. Again, this is just based on what we observe in this sample. There's a lot of material. If you just look at the red material alone, it's about 1/3 the mass of the red-gray chips, which works out then to about 9 tons of active thermitic material. A very rough estimate, as I must emphasize. Our conclusion is that we have found a very energetic, highly engineered, explosive, pyrotechnic material in the World Trade Center dust in abundance. The questions now are, who made this stuff? And why has NIST refused to even look for World Trade Center explosive residues? Also, USGS have asked them. They have not replied. Will they do so now? Now, I want to foresee questions. I don't know exactly how this material was used. I've given some hint, but I don't know. It could be, as we explained in the paper, that just the thin material survived and that thicker layers of this red material were actually used in the building. The point is there's a lot of it, and it should not be there in a commercial building occupied by humans. Details of exactly how they used this to destroy can be learned once we find out who made the stuff in multi-ton quantities. Subpoena power is needed. Again, once you find an accelerant in these photos, thermite was found in the residues of this fire. It proves that there was arson, there was intentional destruction. That's what we have in this case. We have these identified now materials in the World Trade Center dust. The U.S. government oversaw, I think it's fair to say, someone certainly allowed the destruction of 99+% of the World Trade Center steel. That evidence was destroyed. We want to prevent this from happening to the World Trade Center dust. So my concluding slide, the international 9/11 truth movement and community is strong and growing. We can support the New York City CAN referendum. I like that. New York City can do it. They can initiate this investigation. There could be other places, like an international group of scientists, to investigate the World Trade Center dust, for example. We can point people to published papers, their DVDs. It requires of us courage, I believe, and love and truth to take action with civility. And let me just say in closing, just in case, please get your food storage. Thank you.
Like the scientific evidence obtained from crime scenes every day, the scientific evidence that Stephen Jones' team has recently uncovered is admissible in a fact-finding commission or a court of law. It is scientific proof of the specific weapon used to kill 3,000 people.
Thank you.
What's the significance of nanothermite?
The point here is that with the discovery of a high-tech active material, in the words of Dr. Fair, it blows up, when you heat it in a differential scanning calorimeter, as you saw from the narrowness of the exotherm. It's very, that rate is high. Now, we haven't measured everything we'd like to about it, but those data we have. When we compare with known nanothermite, and it's very energetic and very rapid in the reaction. The point is, with the discovery of this high-tech nanothermite, we then feel that it's necessary to insist that NIST look for these materials, to stop pussyfooting around and refusing to look for explosive residues in the dust. And secondly, that we have an investigation in which we ask questions with subpoena power and find out who made this material and who placed it in the buildings and why. In other words, we don't have to explain all the explosives that were there or exactly how they were placed. What we need to find out now is who did it. We have not just a smoking gun, which is the gun after the bullet's out, but a loaded gun, right? It still goes off today. It's coming up on 8 years. Still goes off. Yeah, thank you.
Isn't there more than nanothermite?
The point is there's a lot of data that points to the fact that the official story is highly suspect and has just overlooked so much data. But, you know, there's a lot of data. I think of Minetta's testimony, which I think is very powerful, about what happened the morning of 9/11 in the bunker beneath the White House. No air defenses that day. This is very strong evidence. And when you put all that together, I'm not saying just the nanothermite, you know, that's not the only thing. We've got more and more and more. It just keeps building and building. We have plenty now. We need this investigation that NYC is seeking, or something like it, but I think that's a great initiative. The point is that there's a great deal of information in addition to what I've discussed tonight.
What was Silverstein's insurance scam?
6 weeks prior to the to 9/11, 2001, the owner/leaseholder Larry Silverstein had insured these World Trade Center buildings against terrorist attacks. After the terrorist attacks, he said that, well, since there were 2 planes, he should get double the insurance money, and he collected. I mean, he won that argument. It's amazing. But the point is, again, there's more information. I can't obviously discuss all these things in a short time. There's a great deal of data.
I just want to thank you for your fantastic work, and
Thank you.
I have read
Not just
all-
mine, of course. It's okay. Thank you.
Yeah, well, I have read your papers, and
Good for you. Did you read the latest one?
2 or 3 times.
Wow,
Yes.
great. Huh?
It's excellent, and
Thank you.
the thing that I've been curious about for a long time, I think, with several of your papers is the fact that other investigators, R.J. Lee, the U.S. Geological Survey, and the EPA have all found similar materials, except they haven't bothered to explain them. And I just wonder if you could say a few words about efforts that you've made to discuss this with them, or if they've made any effort at all to explain it.
Good question. We know that the USGS has samples of the World Trade Center dust, and I've written to them and asked them if they observed red-gray chips. They have not responded. I asked this verbally on August 26, 2008, during the public input portion with NIST, a discussion of World Trade Center 7. I asked them if they'd looked for these materials. They just kind of skipped over that. They didn't even say whether they had World Trade Center dust samples or not. That's NIST. With R.J. Lee, I have spoken to one of the principal scientists by telephone. I asked her if they had observed red-gray chips in the World Trade Center dust. They're very, there's a lot of them, and even though they're small, they're very striking to the eye. With even a small loop, you pick these out. Now, this is material that now we've concentrated with a magnet, so it makes it easier. But then they're very easy to see. And I saw that with the naked eye first in one of Jeanette McKinley's samples. It happened to be a large piece. It was about 3/16 of an inch long. It was this bright orange color. I thought, man, that's wild. Look at that. And I thought, of course, early on that might be paint, but it turns out to have all these other explosive characteristics. Anyway, called R.J. Lee, and I asked them, and she said, her answer was, she didn't say yay or nay. She said, well, we did this work for an insurance company, and you would have to pay me to, to check our data and see if it's there. And so I said, okay, let's start an email. And I emailed her. I said, okay, you tell me how much it'll cost, and we'll come up with the funds to have you tell us what you found, these red-gray chips. She never responded. That was the end of that. It's like, I don't want to lose my job. I don't know what was the situation there, but the data are there. With USGS and NIST, these are taxpayer-funded outfits, right? Taxpayer-funded. So they, we should be able to get information from them as citizens and taxpayers. So far, no go, but we should be able to. We're trying. We have FOIA. We have some pretty good people in the community who are using FOIA to try to extract information from these nationally funded labs, federally funded.
I have some questions that are very simple. One is, when was this most recent paper published?
It was published April 3rd of this year, earlier this month on April 3rd.
And what periodical was it published in?
It's published in the Open Chemical Physics Journal.
I see. And have you have any kind of peer review from that article?
First, we had reviewers, and one of the reviewers was extremely diligent. A tougher review than, I've published over 50 papers in scientific journals. This reviewer gave us, it was half a dozen pages of comments and questions, and very good review.
Probably at this time you haven't had opportunity for many to publish any review of your work. So there might be just a blurb or two now to begin with, but nothing of any substance that's come from any great number of physicists on this issue.
It's a good point. Remember that I showed you results from, for instance, this result from Mark Basil, scientist in New Hampshire. And his work is confirmatory, confirms our principal results, and it will be published soon. He wrote to me that he would like to do DSC studies also. He hasn't done that, hasn't been able to get his hands on a DSC. So that will be published soon. It is confirmatory. And by the way, I think this is a valid point. Any objections that you hear, like these crazy, it's really quite a ludicrous idea that this material could somehow be formed just as a building collapses, and then you mysteriously get these red-gray chips. Remember, we did look at the Stardust Resort collapse. No red-gray chips. It was controlled demolition. And the Key Bank, no chips. But anyway, the point is you get these crazy ideas. Well, those cannot be published, but they do increase doubt in, I find, non-scientists' minds who don't understand. People who haven't read the paper. But until it's published, it should not be taken seriously in a peer-reviewed journal. You see, any objections? That's a very good point.
Well, thank you very much.
Thank
I appreciate
you.
your talk.
Thank you so much.
We know that one of the major reasons that they probably did 9/11 was for the maximum, especially the explosions of the two towers, was the maximum psychological effect on the American population. The psyop, so to speak, making us all really afraid. So this, the one question I wanted to ask is would this 10-second explosion of these two towers have been possible by any other means of explosives other than nanothermite, and the time factor in which this new type of nanotechnology was invented was sometime around 2000 or so, and then the brief history, and is there a possibility that it could have been created partially with this operation in mind?
Okay, two main questions. Let me reiterate them so that I don't forget.
A lot of questions.
Yeah,
Sorry about that.
Two main questions. One is the time in which nanothermite was invented, and the second was, could any other explosive be involved? The second question, the answer is yes. I want to reemphasize that. It could be that there are, in fact, nanothermite matches, as discussed in the paper, that were used to set off more conventional explosives. That's just one possibility. Again, the hows we won't know, really, until you can speculate all you want, until you find out the who. Once you get the who's that done it, the who done it, then you can ask them and find out how they did it. It may take some enhanced interrogation techniques. I might say, which I do not favor, incidentally, but maybe there's a a truthful patriot among them.
Could these towers have been blasted down in that 10 seconds the way they were by any other type of explosive other than the use of
The answer
nanothermite?
is yes.
See.
It's quite
What other
possible.
type? What other
C4,
type? Oh.
HMX,
Oh, that could do that.
that
Okay.
could have been used along with or ignited by super thermite.
I see.
Um,
Okay.
Now, let me say, though, we talked about free fall for Building 7, which NIST admitted. The 10 seconds for the towers it's really hard to get the exact number there because of all the dust. But that's not a real crucial issue. The crucial issue is what is this red stuff doing in such quantities in the World Trade Center dust? How did it get there? Do you remember the publications? The AMTIAC publication, for example, showed that the research went back about a decade, and this was a conference discussing nanothermite and other nanocomposite materials. That conference was held April 2001. So again, that's before 9/11. But the report says that goes back a decade earlier, work on these nanomaterials. So that puts you to about 1991. Plenty of time before 2001. That is 9/11, 2001. Also, the ability to make large quantities of metallic fuel, that was in place in 1999.
Okay, thanks.
Thank you.
Several years ago in Oakland, California, a gasoline tanker truck collided with a support column, exploded, and caused the freeway overpass to collapse. And some people in conversations suggest that is an example of how airplanes could have caused the buildings to collapse. Do you have any comments on that?
Yeah. Again, wild hand waving, which could not be published in a peer-reviewed journal. Let's look at this. A photo, April 30th, 2007, Oakland. One section failed. It did not explode. It was a tanker, as you say, caught fire and burned intensely. And as you look at the photo, can you see that there's one section that's intact, and then the next section has fallen. And what happened was there was a failure such that it appears that the bolts actually broke, is the best explanation I have seen in the analysis of this. But this was a partial collapse. The structure below did not fail. This is unlike the towers. This is what we would expect, however, from the towers, had it just been fire that brought them, that was causing the damage. In other words, with other fires like this one, you get a piece of the structure that sloughs off due to the intense fire. That can happen. Bolts failing, for example. But you don't expect the whole tower just to give up, and certainly not in the way that we observe with these enormous clouds formed and then, bone and beams hurled 600 feet horizontally. So taken together, we can expect a partial collapse. So the Oakland collapse actually supports our view that the official story is wrong, because it is a partial collapse, not a complete collapse, whereas the towers and Building 7 were complete collapses. Again, NIST could not explain the complete, total collapse of the towers. You see the difference? So this becomes a point in our favor when viewed properly. I just hate it when there's this hand wave. Oh, look, it collapsed. Well, that explains the towers. What? Have you looked at the data? Do you know? Come on. Does it explain the red-gray chips, for example? No. I see. Couldn't be published because it's just not a complete argument at all.
With your analysis on the really scientifically, and it's great, but my question is, since day one, when 9/11 happened, I refused to believe that Muslims and Arabs did this, and with your analysis at the towers, and with 250,000 tons of steel in each tower become dust, and they find out that the passport of Muhammad Atta is right there. So I just want your humor things about this, because Muslims really didn't do this.
This is a sensitive point, but I think a very good point, and it's in the first paper that I wrote, and it's one of those points that for which I got the most criticism. I'll tell you frankly, there was one professor at BYU that said, you've got to get that sentence out of your paper, and the sentence was that this event has been blamed unfairly on Muslims. Words to that effect, you can read it. And I feel that's very strong, that it's just so unfair. And they've been the Muslim people, I know Muslims, I have friends, they're good, family-loving people, my friends, they're great. I think they're wonderful. And to have this blame, this horrendous event, when, in fact, the official story is a lie, is just totally, I don't have words for it. It's like a crime against humanity is what it is. It's not like, it is.
How do you ignite nanothermite?
This is a photo. It's in a Los Alamos publication. There's the reference down there. Applications include triggering explosives for demolition. This is right out of the Los Alamos report. The super thermite electric matches, set off with electricity, you see. Electric pulse, perhaps from a radio signal, a radio receiver, you set that off, and then you could use this to trigger other explosives like C4 for demolition. Anyway, the answer is that's another way. There may be other ways as well, and those could be investigated. But this is one of the published ways, by Los Alamos National Lab, to trigger the super thermite reaction with an electric pulse. Thanks for the question.
I want to thank you again for coming to the little town of Sacramento. It's really livened up my night. Is this not forensic evidence for a weapon to a murder?
Yeah, it certainly is forensic evidence, CSI style. And I would like to, most of us have seen CSI, right? And they get this scientific evidence, and then hand in hand with that, you've got the criminal investigation, right? That's finding out who. Now, when you find a smoking gun, unless there's fingerprints, for example, you can't tell who. But you can tell from the criminal investigation who by asking appropriate people and getting witnesses. That's what we need now. That's why we need the subpoena power that Jeanette talked about in our investigation. So yes, this is definitely a crime scene, and we do need, therefore, a criminal investigation to accompany the scientific work, the forensic science. Thanks.
Do you have any ideas as a scientist where this volume of this substance that's explosive could be made potentially throughout the world? And do you have any ideas about that? I'm just very curious. Thank you.
So I guess as we begin our criminal investigations, you'd first want to know who could have done it, right? Who could have made multi-ton quantities of nanothermite. As I pointed out, this Amtiac article discussed the production of nanoscale aluminum at Indian Head. Does anyone know where that is? I'm not sure. It's Maryland? Maryland? Thank you. So that's one place to start. Certainly those people there would know. That was 1999. I read that began producing this nanoscale material for this, sort of large-scale production I'm talking about now. And that would be a start. I'm quite certain there will be other places in the world that would have this. I don't have all the answers as to who those are. That's, a very important investigation. And there are people in the community, the 9/11 community, who are looking into that. I wouldn't be surprised if Russia, Israel, China, some of these technologically advanced countries would have that. But I don't know. You have to find that out, and then you start asking.
Norman Mineta, insider whistleblower.
I think Mineta is one of our chief whistleblowers, actually, and should be commended. Here's what he said to the 9/11 Commission. Now, I need to emphasize this testimony of Mineta was not put into the 9/11 Commission report. Go figure. You know why? But it was recorded on video, and so we have that. And he has been asked about it since then, and he insists this was indeed the plane coming toward the Pentagon that was being tracked. Norman Mineta was the Secretary of Transportation on 9/11/2001. He went down to the bunker underneath the White House where Dick Cheney was in charge. And as Secretary of Transportation, he was participating in events. You remember President Bush was in a elementary school in Florida reading about goats while this all was going on. It's surprising in itself that the Secret Service didn't whisk him out of there. It's a danger to the children to have this going on, and he's just sitting there. But anyway, that's another part of the story, another puzzle piece. But here we have in the underground bunker with Cheney in charge, a young man reporting to Cheney, as Norman Mineta explains. Here we go. During the time that the airplane was coming in to the Pentagon, there was a young man who would come in and say to the Vice President, Cheney, "The plane is 50 miles out." Now, pausing. At that distance, there's plenty of time for air defenses. There are Air Force bases near Washington, D.C. It's probably the most protected airspace in the world. We had routinely sent up planes to intercept. You don't just go up and shoot a commercial plane if it's off track, but you do escort it and try to get it to land, find out what's going on. This is routine for the military. They are well trained. It happened over 50 times in the year prior to 9/11. Nothing was done that day, as you know. No air defenses, either for the towers or the Pentagon. So here the plane is 50 miles out. He reports to the Vice President, nothing is done. Plenty of time. The plane is 30 miles out, and when it got down to the plane is 10 miles out, last chance, Mr. Vice President, the young man also said to the Vice President, "Do the orders still stand?" Now here's a young man with a conscience and with some guts to challenge Vice President Cheney and just letting this happen. But the Vice President turned and whipped his neck around. I can see him doing that. And said, "Of course the orders still stand. Have you heard anything to the contrary?" Approximately 2 minutes later, 200 lives were snuffed out unnecessarily. I consider that to be an impeachable offense.
How was the explosive applied?
Well, again, this gets to the question of how. There is a lot of information about access to the elevator shafts, maintenance going on, the fact that one of the Bush brothers, Marvin Bush, in charge of Securicom, in charge of security for the buildings during that period. Again, exactly how the material was done, we won't find out until, you can speculate till you're blue in the face, but you won't find out until we have an investigation with subpoena power that determines who did it. At that point, we should have whistleblowers like Secretary Mineta who can tell us then how this red material was used. What's it doing in the building in multi-ton quantities? Do you see what I'm saying? We need to find out who, and not be distracted just because we don't know exactly how it was done. How can we know that? When you do a CSI investigation, do you know all the details of how? No, not until you find out who did it and why.
Tell us about William Rodriguez.
William Rodriguez is a friend of mine and very good man. Again, this is more evidence that should be brought up before the New York City Commission. He was underground in the North Tower. Is that right, Jeanette? One of the towers, I think, North. And he helped a lot of people get out of the stairwell because there were some doors apparently that were locked, and he had the key. He has that key. And he testified that there was an explosion and that Philippe David, is that his name? That came running out the inner portion of the building there with flesh hanging off his arm. from the explosion. I mean, there's very clear evidence then of an explosion. And furthermore, Willie indicates that when the explosion was, he felt it, and when he felt the plane hit, I mean, he's quite sure that the explosion took place before the plane hit the tower. He's quite sure of that. So that's not, hard physical evidence, but the man's flesh hanging off his arm, that is physical evidence of explosive force in the basement of the towers early on, or very early on.
How were the demolitions controlled?
Probably radio controlled. In other words, I showed you the super thermite matches, which can be set off to explode and in turn explode other explosives with an electric signal. This could be from a radio receiver. You send a certain frequency to that. You set off the explosive in that way. So the radio signal could be sent from anywhere. I mean, there are so many buildings in New York City that would qualify. And it also could have been done from a plane or a helicopter. I mean, once you program into your computer, okay, I want this sequence, I want the explosions to start near where the plane went in for the tower, and then, time later, okay, we got time to program, I want the explosions to start near where the plane went in again, so it looks like that caused all this, destruction, no tamper, but, stuff exploding. But again, with a radio-controlled set of signals going out, and that in turn controlled by a computer, it could have been done anywhere, and requiring just, 1, 2, 3 people finally to initiate that explosion sequence to bring the buildings down. You notice the towers were not a conventional demolition. This was not bottom up; it was top down. We have seen other examples. Richard Gage shows now examples of top-down demolitions. I think the 9/11 Truth community has made it very clear that the consensus is this was not a conventional demolition. And nanothermite is not a conventional explosive, but it is certainly, as we saw in the Amtiak report, quite capable of being used as a shaped charge and useful for demolition, as these reports out of the national labs point out.